Welcome everyone to the International Union of Elevator Technician Community. Here we are going to discuss about three-phase induction motors, which is mostly used in the elevator industry. Induction motors, also known as asynchronous motor. Permanent magnet synchronous motors are also used in elevators. Let's understand about three-phase induction motors. There are mainly two pars in an induction motor: stator and rotor. Stator. It is made up of number of stampings in which different slots are cut to fix three-phase windings, which is connected to a three-phase AC supply. The three-phase windings are arranged in such a manner in the slots that they produce the rotating magnetic field after three-phase AC supply is given to them. The windings are wound for a different number of poles depending upon the speed requirements. Speed is inversely proportional to the number of poles. Given by the formula Ns is equal to 120 F by P, where Ns is equal to the synchronous speed, F is equal to the frequency, and P is equal to the number of poles. Rotor. The rotor consists of cylindrical laminated core with parallel slot that carry conductor bars. Conductors are heavy copper or aluminum bars which fit in each slot. These conductors are braced to the short-circuiting end rings. The slots are not exactly made parallel to the axis of the shaft but are slotted a little skewed for reduce the magnetic hum or noise. Now let's understand the working principle of three-phase induction motors. When three-phase supply is given to the motor, the resulting current generate a magnetic flux. Due to the switching sequence of three-phase current in RYB, the generated flux rotates around the rotor conductor. According to the Faraday's law, an EMF induce in any closed circuit due to the rate of change of magnetic flux through the circuit. EMF is induced in the copper bar and due to this current flow in the rotor. The direction of current can be given by Lenz's law, which states that the direction of induced current will be in the opposite of the motion causing it. Here the relative velocity between the rotating flux and static rotor conductor is the cause of current generation. Here the motor will rotate in same direction to reduce the cause, that is relative velocity, thus rotating the rotor of induction motor. Therefore in this process poles are induces on the surface of the rotor, and these poles always tried to catch opposite poles which are rotating on the stator periphery. Thus rotor rotates in the direction of rotating magnetic flux. Rotor poles always tried to catch the rotating poles on the stator frame. But they cannot achieve the same speed, because if rotor is able to rotate at same speed, there will be no relative motion between the stator poles and rotor poles, and hence there is no change in flux experienced by the rotor, and in that case EMF induce on the rotor conductors will be zero. Therefore rotor always rotate in less speed than the speed of the rotating flux. This is the working of three-phase induction motors. Thank you for watching this video. Please subscribe the IUET Elevator channel for getting this type of videos. Thank you.